I'm Nicolette, and today Brian and I are here with Dr. Reza Chaji. He is the CEO and founder of VueReal, and today we're going to talk about micro LED technology. So thank you, Reza, for joining us today. We appreciate your time.
Thank you for having me.
Why don't you kick us off by telling us a little bit about VueReal's MicroSolid printing technology and what you're doing over there and what makes it different from other micro LED transfer technologies.
Sure. So I guess I can go back a little bit about how I ended up working on micro LED, and that may clear things out a little bit.
Sure.
So my background, I started with CPUs in 2004. I switched to do display and sensors, biosensors and displays. That was part of my PhD. The technology that I developed at University of Waterloo became part of a startup that we licensed to LG. So if you use any OLED TV in the market, is actually using that technology. So I was looking for opportunity to expand that technology to other applications, and at that time, MicroLED was just starting. So we were looking for a partner to find out if we can use our technology and help them to improve their manufacturing issues. So as we were discussing more and more with different companies, we find out that actually the issues is beyond what we can do at the system and algorithm to solve the manufacturing is more complex and need completely different solution. So that's where I kind of built a team and started working on what we can do to solve some of those issues. And we came up with this microsolid printing. Uh, the major difference is the approach we are taking. It helps us to identify a lot of issues in advance before it goes to a display. So we can solve it at point that is lower cost, at the point that it's faster before it goes to a display. So when a defects or non-uniformity or an issue happen at display level, it's expensive to repair, it's time consuming, and it's kind of hard to do it. What our solution enables is to do everything at the LED before it even goes to a display. That's one thing. The other thing is actually we decouple the yield and throughput from each other. So we can solve the yield without affecting throughput. Most of the solution available today, it's either or. You have to compromise. By our approach, we managed to decouple those, and it helps us now to solve one to the extreme and the other one to the extreme before affecting each other.
What are some of those challenges you were talking about early on? What kind of defects were you referring to that you
Yeah.
catch at an earlier stage?
So if you look at micro LED tech displays versus other solutions, so let's say we compare it to OLED. OLED, you do a blanket layer, so you're not doing device by device or pixel by pixel. So as far as you can do a good uniform blanket organic layers, you can make great displays. In case of micro LED, you need to transfer an LED or three LED for RGB pixel to every pixel. So you're talking about millions of LED that need to be transferred at yield, at throughput, and cost. So let's say if the cost of LED goes up by a little bit, you multiply that by millions, the cost of display will go significantly higher. If it takes a little bit longer to transfer LEDs, you multiply that by millions, now you're again talking about uh, and then the same thing in yield. Because of the nature of the display and the difference, this type of display versus OLED or LCD, things could go bad really fast. The yield, because you're multiplying by millions, the throughput, you're multiplying by millions, and the cost. So you need to control every single thing. And that's where most of those solutions suffer. They cannot be in control of all these three at the same time. And then the traditional solution. And that's where the car, you see the TVs that are in $100,000 range. And to kind of resolve that, that's where we came up with this idea that we can address the yield at our cartridge structure that we develop. So let me explain a bit what we are doing for microsolid printing. So let's say you have a great LED wafer. We take that LED and we turn it to a cartridge. And what this cartridge does, it holds the LEDs in place before it goes, and we use it to transfer in displays. The other thing it can enables, we can now inspect all the LEDs in the cartridge. We can bin the cartridges, make sure they are the same performance. If there is a defect in the cartridge, we can eliminate that before it goes to a display. And now we take this, so we solve our yield throughput, our yield and uniformity issue at the cartridge level. And then when we go to a display, we can use multiple cartridge to enhance our throughput. So essentially, we can decide what size of cartridge is good for yield and throughput, for yield and cost, and then decide what number of cartridge we need to improve the throughput for manufacturability. So we did kind of separated the two issues from each other. We can improve the yield without being worried about the throughput, and we improve the throughput without being worried about the yield. And that's kind of help us to control all three parameters independently: cost, yield, and throughput. And we can squeeze it to the level that now we can actually make product that for application that nobody thought it doable. We are now making lighting for automotive, which is the lowest. I mean, it's not lighting is you cannot make it too expensive. So it enables us to tackle those kind of applications as well.
So now, I mean, the micro LEDs are said to be a game changer for things like automotive and augmented reality. How are they doing that? You talked about automotive with some of the costs, but how are they really changing that industry, those industries?
So there are different kind of angle you can look at this. So in case of augmented reality, I guess we
Mhm.
are talking about the ultimate augmented, where you go to immersive experience using the waveguide. The
Right.
optics are not that efficient, especially the most of the waveguide optics. So you're talking about less than 10% or even way less than that efficiency. Now you need to have a display that can also compete with ambient conditions. So if you're outdoor and you want to see the image, it needs to be bright enough. So your display needs to produce millions of nits, so that when it goes through the optics, it expands to a larger size, and you have still you can see it properly. There is no display technology today that can do that.
Okay.
You have to compromise. If you go with OLED, you're talking about tens of thousands nits. Then you have to have a black kind of or dim the environment, or you need to limit how big you want the display to be. So, and if you go to other solution, is the same. Micro LED is the only one at the moment that can achieve such a brightness in a small package. Also, it has to be small because you want to fit it in a glass. So that's kind of more for AR. In the display for automotive, uh, the way I look at LCD and OLED for automotive is always the compromise. There is no perfect solution today for automotive. OLED has reliability issue. It has
Mhm.
great performance, but it has reliability issue. You cannot use it for main application. That's why still main displays in automotive is LCD. LCD has performance issue. So if
Right.
you drive your car at night with LCD, you won't get a black display. You always have this gray background. Uh, Micro LED doesn't have any of those issues. So from performance point of view, you can get very high brightness, you can get very dark black, you can get high dynamic range, fast
Okay.
response time, and you don't have reliability issue like OLED.
Mhm.
So it's a perfect fit there. In addition to that, micro LED can help a lot in terms of system integration.
Mhm.
So one of the things that OLED or LCD suffer is thermal issue. So LCD, you have to have thermal management, and if you don't during the cold winter time, it will be very sluggish. And if
Mhm.
you do with OLED the same thing, it will burn faster, or it will you will have a localized kind of ghosting image. With micro LED, because you don't have such thermal issue, the packaging and the integration become much simpler. So we actually at CES we demoed example of using micro LED in a car, which was a thin kind of layer of glass in front of the steering wheel. You don't have any thermal issue, and it kind of shows a floating image in front of a steering wheel. So the cost of packaging, the space it needs to take, reduced significantly. So not only it gives you a better display, it enables a lot of new integration and design that you cannot get with other displays.
So, what are some of the barriers, to get
Well,
into like, some?
I have a question. I want to piggyback on that for a second because you're talking about automotive and what you showed off at CES there. What kinds of technical demands are there for these displays in vehicles? How how are those technical demands different than in other devices?
So in terms of the technical, there is so for example, it not that you kind of um, completely off compared to other displays. So for right now, if you look at LCD that you use for in front of the car as the main information display, the brightness is around 1,000 nits. You don't get a good black level. You also have thick packaging and all those things. With micro LED, you can go to a few thousand nits, which under the sun condition you can easily see. So you don't need to do kind of prevent the display from environment. So if you look at all your dash, there is a kind of a cover that covers your display or display tilted
Hmm.
somehow that it doesn't get in front of the. So it's some barrier to the design. You cannot put display anywhere. It has to be kind of some design consideration to it doesn't get affected by ambient. You don't
Right.
have that issue with micro LED, so makes the design easier in the car. Uh, One other thing that we also demonstrated in CES is this display. They can be very transparent. So we show that display that has almost laptop type resolution
Hmm.
with over 60% transparency. So if you compare that to OLED or LCD, other those, for example, OLED at TV resolution, which much larger pixel, they only 40% transparent. So now this display you can laminate to the glass, to the body. It doesn't interfere with anywhere in the. So it enables. So one of the and the same thing with lighting. We also show lighting with high transparency, very thin profile. So one of the car designer who was visiting us CES, he said, I had to always design around the lighting and display. Now this could be part of my design.
Right.
It
So,
enables some of my design, which is a completely different way of looking at it.
Right.
how is this going to affect devices like smartphone as it gets sort of integrated into things like smartphones, tablets?
Yeah. So OLED and LCD, they're not sitting still, so they're fighting, they're improving the performance. So the game is changing day by day. So my take is that for consumer, um, uh, micro LED cannot win just on performance. So
Mhm.
if you compare just on performance, it's not going to be a big win. It has to be some extra things that micro LED can do that, for example, OLED will have issue or it won't be able to do at good as good as micro LED displays. Um, so high brightness is one of those. So you can make the display brighter, better. So it's for especially for phone and watch. That's a big requirement. But what's one thing we showed, for example, again at CES, is that you can leverage micro LED kind of pixel real estate to do a lot more. So let's say if you look at the watch, for example, you're
Mhm.
talking about 60 micron pixel.
Yeah.
The area that LED is taking, because these are very small LED,
Hmm.
it's maybe 30%, 40% of that pixel. So you have 60% empty space that you can do more. So we show that you can put that solar there. So, and then we did some calculation. If you do that for an Apple Watch, you won't need to charge it again. So your Apple Watch can charge itself. I was joking with one. I said, I have an Apple Watch and it has a sleep tracking. I never use that feature because my watch is always on the charger at night.
Right.
Imagine I use that feature.
Right.
So
Right. Yeah.
and it also can help companies like Apple's or Google's or Samsung to reduce the battery pack, make their device more compact, make the device. So it has also some implication on cost, on the design, and also usability. The same thing you can do with the phone. You can integrate sensors down the road, and then your display can do advanced HMI or some biometric security that was uh, beyond what OLED can do. Everybody is looking at the camera under the screen. There is still
Right.
not perfect. Either the camera suffer or the display suffer with micro LED because the LEDs are big. They're not going to block your camera. It's a perfect solution for those type of things. So it has a lot of features that other display cannot do. So it's not just performance. What I think micro LED need to show is that it's beyond performance. It can help the system integration
Mhm.
much simpler and offer solutions that those display cannot.
So how do you think that's going to affect design in the future, right? So you just talked about like you could have your Apple Watch and may never charge it again. How's that going to affect design from, for the design engineer's perspective when they're designing a consumer advice device?
So one thing, they don't need to be worried too much about fitting a big battery.
Okay.
They don't need to be worried about kind of turning off the display, because the battery, the display can be on and it still will be survive the battery time that they need.
Mhm.
So it will kind of both affect the HMI and also would affect the overall package that you make the watch in this case. The same thing on the also it will have a big impact on the phone, the same way that is
Right.
impact the watch. One area that we are doing some advanced development in collaboration with our partners is also microsensors integration.
Right.
That impact would be, especially on watch, would be way more. So when you look at today's watch, they have one or two sensors in the back. Imagine you have thousands of sensors and much lower profile than this big crystal in the back.
Right.
Now you can collect tons of information. This could personalize health. You're not collecting just few different things. You can collect biometrics, you can get biomarkers, you can collect a lot of different information that you can now, with the help of AI, you can actually do some health monitoring and some recommendation, personalized kind of diagnostic. That's the impact that it will have in future, and that's actually my uh, interest and my dream to get
Right.
there. It's going to take time, but that's what we are shooting for.
Are there any, you talk about a watch, are there any thermal management concerns that you have in regards to micro LEDs, especially in those compact applications?
That's actually another unique features of micro LEDs. They're so efficient.
Mhm.
Uh, so that you don't need to be worried too much about thermal management.
Mhm.
So one of the things that we demoed at CES, we had this lighting solution for automotive, and this we were running them at 20% peak brightness, but you couldn't still look at them. They were crazy bright. And one of the things we asked people, I said the display was just half a millimeter piece of glass, and said if you touch it with this brightness, if you it's a normal LED or normal lighting, you would feel the heat. It will burn your hand. And we had no thermal management, and they didn't feel any temperature change. So that's the beauty of micro LED.
So how do you ensure the consistent reliability of across so many micro LEDs?
That's actually one of the things we offer, because we do cartridge level inspection, making sure all the LEDs are good before they go to the display. That's actually one of our feature or selling features.
Just a moment ago, you said it's going to take time, right? What are you working through now before you see this kind of widely adopted?
So the take time is more was on the microsensor side. So the same
Okay.
way that we do micro LED is also microsensors. Uh, the way we are kind of looking at the market, we kind of our main focus since day one been on automotive, because we are addressing some pain point that the other display cannot address, and that is always the best market to go. So as one of my colleague used to say, he said, if you are a painkiller, is much better than a multivitamin. People, they have to buy painkiller, but they don't have to buy multivitamin.
Right.
So for automotive, we are a painkiller, so we can actually solve some of the pain issues, both in lighting and display.
Mhm.
So that's been our focus. What we learned from that market, we actually been working with that quite a bit. We already passed a lot of qualification, and we are getting our certificate to be an automotive manufacturer in 2025 and start
Right.
shipping product 26. What we learned there, now we are scaling to consumer. So the one that we showed for example, for watch with solar, or
Right.
what we are doing for AR, those are going to be kind of building on our experience in automotive and serving the consumer. Consumer market is always higher volume, so the supply management, the supply chain, the reliability need to be much more robust than
Mhm.
lower volume automotive. So that was a good practice. and then you can take that, scale it, and address consumer market. In consumer market, also we think watch is the first, phone is the toughest from a
Gotcha.
couple of point of view. One, nobody make few 100,000 phone or million phone. Everybody, especially the brand that you need to go for, because the low cost brand, they're not going to use the new technology. The high brand, they are in tens of million phone
Yeah.
a year. So you need to be able to scale to that volume. That's the first thing. The second thing is cost. Uh, a phone has the same number of pixels as a TV. That means you have the same number of LED as a TV. So now
Mhm.
you need to compact the TV solution in the cost of a phone display. So those are the two main challenge that kind of make the phone the most challenging product.
Mhm.
But in our projection, in our path forward, and the way we are moving, and especially using leveraging our microsolid printing, we think that there is a significant kind of opportunity in the phone, not in the next year or two, but in the next before 2030.
Do you think it's going to create more sustainability in electronics manufacturing?
That's one part of it.
Mhm.
So if you look at today's the way they make the display, so they have this huge vacuum chamber that they deposit material and do all the processing. So everything need to be scaled at that. So because of that, so they consume a lot of power, consume a lot of water. This vacuum chamber, they are in the size of a master bedroom. Some of them they're big, they're massive, and they need to make it more vacuum than actually the actual vacuum in the space. So so this takes a lot of power, a lot of energy to do that. And that's why you see the only few places can do it because of the cost of building that, and the managing and operation cost is so high that you cannot do it on a small scale. You have to do it at high volume production, and only few places in the world is doing it. Micro LED can change that completely. Right now, we are leveraging existing foundries to produce the LEDs on a smaller wafer instead of a large glass, and then we distribute them on a large glass. So the material you use, the power you use, the water you use, the chemical you use is significantly reduced because you don't use those on the larger scale. You make very small LED on a smaller wafer, and then you distribute them on a larger display glass.
So you mentioned that things are moving with automotive with that industry, but in general, where do you see this micro LED technology in 5 or 10 years? Do you see it more widely adopted?
So, as I mentioned, one of the advantage of micro LED is beside the performance and beside what it can offer from reliability and performance, it can help a lot on system integration side, either through thermal kind of budget that they have, they don't need to worry about them, or through some extra functionality like solar, micro solars, or micro sensor. So those features are needed for advanced application. As we are moving more toward kind of AI driven and immersive experience driven market, you need a lot of those things. Your phone need to be 24/7, your watch need to be 24/7. You need to have a smaller, more compact, you need to have more sensors integration. So because of that, there is the micro LED is a matter of when, not an if. The challenge that prevented has been always cost, how to reduce the cost. And that's where VueReal kind of play a big role. With our microsolid printing solution, we did some calculation comparing to existing displays, this existing solution that they do micro LED. We can bring the cost down to 2 to 4 times already. We can use low cost micro LED that nobody could use before and make a display. And that's we can now leverage our strategy in terms of managing the challenges at the cartridge level and binning and all those things, and produce high-end displays with low cost LEDs. So combination of those kind of put us in trajectory to be able to even go to market like phone in the next few years.
So where can we find more about VueRail's micro LEDs?
So we actually just redesigned and revamped our website. So there are going to be tons of information posted there. We also this year, in order to accelerate the market adoption for micro LED, we offer three different sets of design kit. So one is more for transparent displays, so that people can actually go order on a website, get these transparent displays, and plug them into their application, see how it can enhance their solutions or what type of new design they can do. We are offering a lighting solution, the design kit that they can use it either for automotive, retail, any type of lighting, and then also an AR design kit. So those will give them some idea in terms of the performance of micro LED and how we manage to enhance that. And then in terms of what we do and how we do it and the team and who is behind this, they can see on our website. One of the unique things also we're offering is based on our business model. So VueReal doesn't want to be the in control. We don't want to be the one who solely produces this stuff. We actually want to offer this platform to everybody to use and produce product. Our focus is going to be providing cartridges to people, and they use this and start developing and designing their own product. So if by doing that, we think there's tons of smart people out there that they have a lot of ideas that if we give these tools to them, they can come up with a lot of solutions that we don't even know today. So the way I'm looking at it, this is going to be the smartphone of hardware application. What the smartphone did for software in terms of Airbnb, Uber, nobody at that time knew these are going to be a market. And now we have huge market for those. This could do for hardware. So if we provide cartridges that with sensors, with the micro AI, microprocessor, all those different things to people and allow them to integrate them on the surface at mass, they're going to come up with a lot of application and design that nobody knows today. So that's our goal, and that's how we are developing. So we are building a huge ecosystem of partners that they support different part of this business model, from micro device, micro LED, micro sensors, to tools, to materials, so that then our customers and partners, they don't need to be worried about this. We have a verified supply chain. They just need to tap to that and use the solution and design their product.
Wonderful. Thank you so much for chatting with us today. We learned a lot.
Thank you. Thanks for having me.